which is the case as now and will always be, because NASA's very excellent at supporting these missions. However, that to me is the most important thing. You know, okay, I'm fully onto this mission, and I know this equipment is going to do its best to get us there and back. And that's kind of what we do in the space station. We're really running through the systems and making sure it's all up to par.
In terms of the systems that we have to try to make sure that the human beings can function over a long period of time, what are the areas that are most important? Is it the bone health you referred to before?
You know, bone health and radiation is important, but when you get to some place, it's probably going to have a little bit of gravity, and specifically I'm talking about Mars. So you want to be strong enough to strap on a suit that has some mass to it and walk around and do heavy tasks, because spacewalking, either on the space station or with your footprints on a red, dusty planet, is still hard work. And so I really think that it's of the utmost importance that you can maintain good physical health to be able to carry out that hard work when you get there, because that's the whole reason you're going. That is the mission. So you don't want to sort of turn into a cream puff when you get out of the capsule on the planet.
We've referred to the fact that there are a lot of experiments that you'll be a subject for. Can you give me 2 or 3 examples of the kinds of human life sciences research that you're going to be involved with on this mission?
Well, I talked about the bone health, and one of the experiments is a spine, ultrasound of the spine. Now, that's really not a common practice on Earth, I'm told, because we have better technologies that can give a higher granularity of what's going on in your back. However, most parts of the planet don't have access to MRIs or some of these more expensive things, but ultrasound is a very now inexpensive and can come in small briefcase size packaging. So that, in my opinion, would spread to lots of places on this planet that don't have the means and the financial wherewithal to get this expensive medical equipment. So I think that's a really exciting and important technology we'll be demonstrating, is spinal ultrasound, not only for the technology but also to what we're going to learn about our own spines and how they react. There's some nutrition studies. I'll be part of a specific period of diets where there's a relationship between the potassium and protein in my meals for 4 days, and they change the ratio to a high and low on a different set of 4 days. So that'll be another experiment conducted on myself. And yeah.
So there's a lot of different kinds of things, and just being there is an
just
experiment.
being there, exactly. Just being there itself is an experiment all by itself.
In the meantime, you're going to be working with some specialized equipment that's there for laboratory research in other kinds of scientific disciplines other than human life sciences. Tell me about some of those other kinds of experiments that you've been preparing to work with on the station.
Right. Well, everybody likes to play with fire. And there's a combustion experiment that I just received training on this week that I'm excited to participate in, and some really unique fluids experiments that are looking at capillary flow and how do you make fluids go where you want them to go in the absence of gravity, so that it's not all falling to the bottom of the tank, and how do you make it move in the direction you want to, and so you don't lose some valuable consumables. You know, if you can't slurp up that last several gallons of fuel, it might not get you might fail the mission. So you want to be able to use all that fuel in the tank. And so some of these fluids experiments are along those lines as well. And I just was told recently that there might be some more fish flying. Aki Hoshide started out with the fish experiment. I think Kevin Ford finished it up. The aquarium is still there, but I believe that there'll be a new batch of fish flying up to do more studies, and that's along the bone health side of the house also. It's
quite a range of different kinds of work that you're going to be involved with.
It really is. That's what I think is exciting. Here on Earth, I enjoy when my days, different days of the week have different activities, and it makes, before I know it, the week has gone by fast. And that's what I think the space station, living on a space station will be. There's so many things that need to be done, and experiments. At 1 minute, you're a research assistant conducting an experiment. Literally, the next hour, you could be a plumber or a mechanic changing out something that's a critical failed piece of equipment that needs to be fixed so that the next experiment can be conducted on time and with great deal of success. So that's what I'm really looking forward to. I'm a kind of a garage tinkerer anyways. I like to fix stuff and repair broken things in my house, so that appeals to that side of me, the maintenance part of everything.
That's another part of what you do is what you do with the time when you're not a science experimenter. You're responsible for making sure that the station, all its systems, as well as all that science equipment, that everything continues to work. Give us a sense of what a day is like for a space station crew member. What do you do during an expedition?
Yeah, so just on Earth, you know, we've all moved into houses that are a little bit old at one point in our lives, and somewhere in there in the 10-year mark, everything starts to kind of be a little less reliable, and that's, I think, where we are with the space station. So mechanical things break, and mechanical things need maintenance and repair, and other than the science activities, we do just that. I think just this week, Chris Hadfield and Kevin Ford are repairing a valve in the Columbus, a critical valve in the Eclipse system in the Columbus module, that will regain some key capability for the Columbus activities. And that's a major event that I know the European Space Agency is excited about. And that's just one example of things that creep up in a given week all the time to be repaired. And so what is a day like for an astronaut? You know, we'll get our weekly look ahead on our calendar, on our timeline, and sort of see, okay, this is a heavy payload day on Monday, and it looks like I've got a lot of maintenance activities on Tuesday, and sort of think that you have that plan, but then it completely can change as soon as there's some erroneous alarm and the ground calls up and says, hey, we're going to need to shift priorities and refocus our efforts on this piece of equipment because that's critical to getting everything done.
Several minutes ago, you made reference to the fact that on a shuttle mission, everything is very tight and you have a schedule that you got to keep. It's not that way on the space station, right? You have time to relax. You have off duty. You have weekends off. I mean, things. What other kinds of things like that are there to help crew members live over this extended period of time you're going to be away?
Right. Great question. So we're living on, just to kind of set the stage, we're living on London time because there's centers all around the world. So Greenwich Mean Time is when we're waking up. We'll wake up, and then around equivalent of about 7:30 in our morning, we'll have a conference with the ground, sort of set the stage for the day, and then embark on our work day, which does have lunch in there. And then at the end of the day, we'll conclude with another conference for the ground to sort of tie up any loose ends and briefly talk about the next day's activities. So outside of those daily planning conferences, what do we do? Well, just like here on Earth, as soon as you put your feet on the floor from when you wake up in the morning, you're not instantly at work. There's a period of time where you use the restroom, you get dressed, you take a shower, you have your coffee, you eat your breakfast and read the paper, all those sort of things. We have a similar activity called post-sleep, and generally that's not a relaxing thing that you kick back and do. That's preparing for the workday. But on the other end of the day, there's a thing called pre-sleep that sort of encompasses what happens after work here on Earth, where you drive home, you stop at the grocery store, you get a new thing of milk, and then continue on home, relax with your family, watch a little TV, read a book, and then prepare for bed and go to bed. That's pre-sleep for us, and you can spend it in a variety of different ways. In some busy weeks, maybe it's looking a little bit ahead for what you have to do in the coming days, but really the relaxing, you need a little bit of time to unwind and relax, and that's, in my opinion, the time to go look out the window, take photographs of your crew doing sort of other than work activities, because that's a fun thing to capture too for ourselves and for our families and our loved ones back on Earth. and just looking at the planet. I equate looking out the window at the Earth kind of like when you go camping and you could just sit and look at the campfire for hours, be mesmerized by the flames doing things and adding wood, and it just captivates your attention. That's how the Earth was for me when I was up on the shuttle. I could have just looked for hours and hours and hours at the planet going by underneath.
And over the course of a week or the months, you get a chance to talk to folks on the ground and your family, so it helps break up the isolation a little.
Yeah, it sure does. And those types of conference calls on the weekends we'll have with our family. They have a phone, IP phone we call it. It's basically a computer program that you can call a regular telephone, given certain satellite coverage. And it's fun to call your friends and say, hey, I'm calling you from the space station. Looks like you're having crummy weather down there in Houston.
So you're rubbing it in.
Rubbing it in. Yeah, it's all sunny up here.
Besides all of the work that you folks do inside the station, there are times when crew members have to go work outside the station. Now, this plan could change, but right now there is a plan for spacewalks during your mission. Give me a sense of what's going on. Because there's a lot of spacewalks on the plan as well. Who's going outside to do what? And particularly, what is going to be your role when it comes to these EVAs?
Right. So it's an international space station, so we have international spacewalks. The Russians are planning for 4 spacewalks, and largely what they're doing is preparing their tasked to prepare them to receive a new module that will arrive after we are gone later in the year. The exact date has been moving around, but many tasks to run cables, prepare the equipment for that module to come. The Russians have the crew complement for those EVAs is they all rotate, so I think each and every one of them will have the opportunity to get out the door, and those spacewalks are sort of spread out throughout the increment. Recently, there's been some discussion of adding maybe 2 or 3 U.S. spacewalks in the summertime, June-July timeframe. We'll see how it all works out. If we do get that opportunity, it'll be Luca Parmitano and myself, and a couple main tasks. One of them, there's some piece of equipment called the radiator grapple bars that are being brought up by the SpaceX that will be launching here in the beginning of March. And these are large metal beams that are used to grab onto a radiator once it's collapsed and folded down if it needs to be repaired, so that a robotic arm can move in and grab it and take it where it needs to go. When the SpaceX arrives, these grapple bars will be placed on a piece of equipment called the POA. Payload, I'm not really sure what POA stands for.
It's an assist. It's a place to store it.
It's a place to store these grapple bars. The key thing about the POA, though, is it's a place to store any equipment, and if other pieces of equipment break, that's a planned location for these major repairs to be held temporarily if it takes multiple spacewalks to conduct the whole replacement of whatever part is failed. So that location is one that we tend to protect and have it be available if we can. So our job will be to take these grapple bars off of the POA and go place them in one on each side, port and starboard of the space station. That'll take a large part of one EVA. The other major task that we're looking at, lately the SARJ, the rotary joints, solar array rotary joints, have shown indication that it's taking more current to drive the motor to make them spin, which indicates that maybe there's some binding or it's not smoothly spinning around the ring.
And these are the joints that are out on the truss, outside of which are the solar arrays that rotate to follow the sun.
Exactly. And they're big. They're large. They're, I don't know the exact diameter of them, but it's on the order of probably 15 feet. It's very big, a big ring. And so the engineering team is right now looking at what's the best way to tackle this problem, but it will involve some type of cleaning or lubricating of these rings, on both sides of the space station. And the task in and of itself is much like squirting a caulk gun that you'd purchase on any home improvement store here, but it's getting access to where you would squirt that beta-cock that is the overhead involved with these spacewalks. So those are all up to par.
In terms of the systems that we have to try to make sure that the human beings can function over a long period of time, what are the areas that are most important? Is it the bone health you referred to before?
You know, bone health and radiation is important, but when you get to someplace, it's probably going to have a little bit of gravity, and specific, which is the case as now and will always be, because NASA's very excellent at supporting these missions. However, that to me is the most important thing. You know, okay, I'm fully onto this mission, and I know this equipment is going to do its best to get us there and back. And that's kind of what we do in the space station. We're really running through the systems and making sure.
Give me 2 or 3 examples of the kinds of human life sciences research that you're going to be involved with on this mission.
Well, I talked about the bone health, and one of the experiments is a spine, ultrasound of the spine. Now, that's really not a common practice on Earth, I'm told. I think that it's of the utmost importance that you can maintain good physical health to be able to carry out that hard work when you get there, because that's the whole reason you're going. That is the mission. So you don't want to sort of turn into a cream puff when you get out of the capsule on the planet.
We've referred to the fact that there are a lot of experiments that you'll be a subject for. Can you...
Particularly, I'm talking about Mars. So you want to be strong enough to strap on a suit that has some mass to it and walk around and do heavy tasks, because spacewalking, either on the space station or with your footprints on a red, dusty planet, is still hard work. And so I really